part 2 of the study guide video for section 5.1 and 5.2. I went ahead and combined the two because they're pretty much over the same topic. We'll start with V. This is a division problem. So if you look right here, it says subtract the exponents. -9 take away 2 would be -11. So this is x to the -11th, which is the same thing as 1 over x to the 11th. Another way you could have done this is you could have moved the x to the 9th to the bottom, made it positive, and then combined these by multiplying, which would result in adding the exponents. Okay, I've got another one here. We're dividing the same base. We're going to subtract the exponents. 4 minus -3 turns out to be 7. So we've got 5 times p to the 7th. Okay, on x, 2 to the -3 divided by 2 to the -1. We are dividing the same base. We're going to subtract the exponents. So -3 minus -1 turns out to be -2. On a negative exponent means division, so we're going to divide by this. We're going to put it on the bottom. To the second on bottom, which is 1/4. Okay, on y, again, we are dividing the same base, so we'll subtract the exponents. -8 minus 3 is -11. This is z to the -11, which would be 1 over z to the 11th. On z, we are going to be dividing the same base again. We will subtract the exponents. 3 minus -5 is +8. So I'm going to have 7 times t to the 8th. Okay, and that is it on the study guide for the first examples. Before we do the example 2, it's important to state that sometimes these can take more than one step, and if you do, it doesn't really matter which one you do first. Sometimes there's a little bit of preferences because doing it one way will make it easier than another, but really it doesn't matter which way you do it. For example, on A, if you wanted to move the x to the 7th to the bottom to combine it with this x to the 1st, you could. Or we can just plot along following the rules. So anyway, the rest of these will have more than one step, and I'll try to work through them kind of quickly here. Okay, this one is dividing the same base. It also has some negative exponent, but we can take care of that later. So the 2 over 10 reduces to 1 over 5. It's not exponents, but on these where I'm dividing the same base, I'll have to subtract the exponents. -7 minus 1, because this is x to the 1st, would be -8. So I've got x to the -8th, and then y to the 2nd divided by y to the -5th. You'll have to subtract the exponents. We get y to the 7th. Because this one has a negative exponent, I will move it to the bottom of the fraction bar. And we end up with 1 times y to the 7th. Oh, 7. Divided by 5. And this x to the 8th is coming to the bottom. Make sure that you write it with a positive exponent after you move it. Okay, B, we are going to be multiplying the same base, and then we're going to be dividing the same base. I'm going to multiply first. The 3 is just a coefficient. Nothing important happens with it. X to the -3rd times x to the 2nd, we will, because we're multiplying, we will add the exponents. -3 plus 2 is -1. So I have x to the -1 divided by x to the 6th. Now we're dividing the same base. When I divide the same base, I subtract the exponents. -1 minus 6 is -7. So we end up 3 times x to the -7. And that's going to be 3 over x to the 7th. Notice the 3 didn't move. The 3 does not have a negative exponent, just the x. Okay, so the x term was the only thing, or I shouldn't say the term. The x and its coefficient. I'll get this right eventually. X and its x and its exponent was the only things I moved. All right. On C, it's going to be dividing the same base. 5 over 15 reduces to 1 over 3. I'm going to extend this because I don't know really where we're going to end up with things. I have a to the -5th divided by a to the 2nd. I have to subtract the exponents because it's divide. I end up getting -7, so it's a to the -7th. Alright, we have b to the 3rd divided by b to the -4th. So 3 minus -4 turned out to be +7. Because the b has a positive exponent, it will stay on top. The a has a negative exponent, it will go to the bottom. So 1 times b to the 7th over 3 times a to the 7th. Okay, we'll continue with D. This has multiplying, so the 2 is just coefficient. The x to the -5th times x to the 6th. The rule for multiplying is you add the exponents. -5 plus 6 is +1. So I have x to the 1st on top. And we have x to the 5th on bottom. Now this is dividing, so I will subtract the exponents. 1 minus 5 is -4. And because it has a negative exponent, I will write x to the 4th on bottom. Alright, this next one has looks a little tricky. Just don't panic and realize we are multiplying the same base. We're going to add the exponents. So when I add the exponents, I get 3a plus 4. And we'll just write this as x raised to the 3a plus 4. Because we don't know what a is, we can't really simplify it any further. On f, it's dividing the same base. I'll subtract the exponents. So I have 3t minus 2 minus t minus 3. I'll need to rewrite this to simplify it. (3t minus 1t is 2t. -2 plus 3 is +1. This ends up being x raised to the 2t plus 1. Alright, looks like we get a little bit of a break here as far as raising a power to a power. This is a new one we haven't talked much about. It's rule 3. If you raise a term to a power, you're going to multiply the exponents. So x to the 5th raised to the 7th would be 5 times 7 is 35. Next one would be 5 to the 4th, because 2 times 2 is 4. Next one would be 3 to the -3, because -1 times 3 is -3, and then I need to simplify this by writing as 1 over 3 to the 3rd. 3 to the 3rd is 27. 1 over 27. X to the -4th time raised to the -6. -4 times -6 is +24. So this is x to the +24th. So even though it kind of sounds a little complicated, raising a term to a given power, you will just multiply the exponents.